So let's start. First of all, thank you for being here, and welcome to our Grails application performance talk. My name is Alberto Barón. I'm a software engineer at Salenda since 3 or 4 years ago, and I work with Groovy and Grails developments every day.
And I'm Alberto de Ávila, and I'm also a software engineer. I work as a team lead in Salenda, and I've been working with Groovy and Grails since 7 years. And I will give you a big applause for my friend Alberto, because he's the first time speaking in English, and he's a little nervous. So, Alberto.
So, as I told before, we work in Salenda, which is a software factory based on consulting, training, and developing about Groovy and Grails applications. Moreover, we are Atlassian partners, and since the first edition of Greach, we are really proud of being sponsors too. If you have any doubt, we are outside, and you will answer you.
So let's start talking about goals of this talk. We want to show you a few different ways to improve performance. There are a lot of more, but let's review some. We want to show you also good practices, common mistakes, tricks and tips, and a few tools to measure performance.
So what are we going to see here? First of all, we are going to see the improvements outside Grails application, because not always the problem is inside. Okay. After that, we are going to see the improvements inside Grails application, focusing on config and code changes. And finally, Alberto is going to show you some tools to size your performance.
So, what about improvements outside our Grails application? Let's comment only 2 minutes. We have hardware improvements, and we have inside the software improvements, we are going to speak a little about architectural changes, JVM parameters, and database.
So what can we do for improve our hardware? First of all, we know that we have to use a good hard disk, for example, a static solid disk, instead of the traditional magnetic disk. Okay, we can increase the RAM memory. We can use microprocessors, which implies in more velocity and more cores. And we can use a good network, because if you have a good microprocessor but not a good network, it's the result.
So, what about the architectural improvements? Architectural improvements are done when you have a high load in your server. And how can we fix it? We can have, for example, multiple web server instances with load balancers, proxies, or using, for example, message querying, use multiple database, or even change the architecture of our application to use microservices. When you use microservices, you can then rescale the microservices that are most used. And this is what happens when you improve your performance at architectural level.
So according to Java Virtual Machine improvements, what can we do? You know that we have parameters that you can insert into the virtual machine options. As we see in that image, the 2 first parameters are referred to Java space memory, and it implies to save Java objects. Okay, and the last 2 parameters are related with per gem space and it's related to the saving of metadata, such as class objects or even methods. Okay, in Java 8, the permission space disappeared, so those parameters are ignored, and a new flag appears, which is the max metaspace size, which is the substituting of that parameters. Okay.
So be careful with the JVM parameters. And what about the database improvements? Sometimes we forget about database, but this is a very important piece of our applications. And the first thing that we want to recommend you is to monitor your database, because monitoring your database will show you slow queries to fix it, and then the most used queries. So you can improve the most used queries because it will be better for your application. Another thing that you can do to improve your database performance is to create database views to execute complex queries, create more indexes than the defaults. Think about your model and create a good data model, because sometimes the Grails developer forget about our tables in our database, because we only create our domain class and forget about the rest of the things. But we have to think if our model is correctly created. And one only last thing, think about that question. Do you only need relational database? Because we can create an application that has two databases, one relational and one non-relational. The non-relational for querying, and the relational to get the persistence. So this is what happens when you don't care about your database.
Okay, so we are going to start about improvements inside. According to configuration improvements, we are going to start with Bootstrap. What can we do with Bootstrap to improve our performance? First of all, it's something obvious, but include the less code possible. Moreover, you can configure it by environments to load resources depending on the environment you are. You can use the migration plugin instead of insert data in the Bootstrap file, and you can use even promises. Okay, so sorry. To configure by environments, you can use the class environment, which allows you to insert different resources in different environments, or even to create a custom environment, such as the last one we have here. Okay. Moreover, you can use the migration plugin instead of insert data. The migration plugin is used to manage database changes, avoiding inconsistencies. And the goal of that is to create a main file, which is the changelog. And inside that, you can include different files, which are used to different changes per branches. Okay. And moreover, you can even use the plugin to insert scripts in Groovy, for example, to change your database. And the last one, promises, it's a concept in asynchrony that you can see more concrete in tomorrow's talk at 8:30 about testing optimization. Okay.
Another configuration improvement is the Hibernate cache. Hibernate cache is a second-level cache that is located between the application and your database, and it can be used in 4 ways. And the read, that is the most used policy. The read-write, the non-strict read-write, that is created for application that performs a lot of reads and only a few writes operations. And the transactional policy that enable us to cache all the operations done in a transaction. So how can we use the Hibernate cache? We have to add the dependencies to your projects. Depend on the Hibernate version and the Grails version. You have to add it one on another. Then you have to add a config like that, enabling the second level cache and using the provider and the factory class. In the official doc, you have explained what class do you have to put there and what are the main functionalities of each class. Then in your code, and for example, like that, you have to write in the mapping block something like that, the cache usage and the policy you want to use. Then you will have captured the results of this domain class. Another way to use the Hibernate cache is for caching relationships. Like in the sample, you can cache the wheels relation. And another uses of Hibernate cache is for caching queries, specifying the cache true parameter. You will catch the results of this query using the same parameter passed to the query. But be careful with cache. They are dangerous, okay? Code improvements. The first thing that we want to mention is use the compile static annotation, because the compile static classes are better in terms of improvement. And the second one is querying.
Okay, so you know that in Grails we have 5 different mechanisms to do queries. The first one is the dynamic finders, which GORM provides us on-the-fly methods that allows us to do sample queries. To do more sophisticated queries, we can use where clauses. For projections and restrictions, we can use criteria. And finally, we can use HQL and SQL to do queries such as in databases. So what things can we do with that? You have to be clear and don't abuse of dynamic finders. You have to avoid to filter or sort queries results. You can use left joins and projections with criteria. You can flush the session in little batches to avoid memory errors, and give Hibernate stateless sessions a try.
Inside the domain classes, we have 2 ways to improve the performance. First of all is auto-wiring. Auto-wiring services are injected every GORM query result and every new domain class instance. And what does this mean? If we make a query and it returns, for example, 200 entities of a class, then the service will be injected in all of these instances, even if we don't use it. And this could be a bad performance result. For that reason, since in Grails 3.3, auto-wiring is disabled by default. So how can we fix that? We can create an Anemic domain model and move all your logic to our service layer. We can use Taglibs to get logic access in the view layer. We can lazy load services. That is a bit difficult, but it's possible. Or use GORM event listener. That is a new Grails 3 feature that you can create listener classes to listening the current events like save or update or delete to perform logical operations inside the listener. So be careful with auto-wiring. What about has-many relations? The has-many instances are lazy loaded by default. That is good. But when you add a new instance to the has-many relation or remove one, all the instances are loaded. So it can be a bad performance with entities that are too big. Okay. So how to stop using has-many? We are going to see the two ways, the one-to-many and many-to-many. In the one-to-many, we have to delete the has-many relations and relate the many side with the owner. Let's see an example. Suppose that we have a class person that has many cars in the class car. We can convert this to this other code, a class person and a class car, and the class car has a new attribute with the owner of the car. And what about the many-to-many? And in the many-to-many, we can do like a Spring Security user role relation. You have to let the instance orphans map the join relation, and you have to create some helper methods to use the new relation or finders, like create or remove instance or finders. A sample of this. We have the same person class and the car class, and then you have a new person car class that you can see here with the two classes mapped and two methods, the create method and the remove methods. We have added to the person class new methods to find all the cars for that person. So if you do something like that, you will lose automatic cascade. That means that you have to delete manually the instances because you lose the cascade, but you evict the cascade problems that sometimes we have. You can use add to and remove from methods, and you will have to implement some methods like getters or finders to access to the same functionality that we will have if we use the has-many relation. So, but not all the models or not all the applications are applicable to this solution. You have to study your model, take performance measures, and then decide if you have to use this approach or continue using a has-many approach. So, be careful, okay? When you're using has-many.
Okay, and now we are going to see the improvements in logs, okay? First of all, we are going to see the concept of asynchronous appenders. An appender is a class which delivers the log events into the destination, and the AsyncAppenders are appenders in multi-threading, okay? So let's users log events asynchronously. The way to work, to pass the message from the main thread to the rest of threads is using an array blocking queue implementation, which is a FIFO queue that doesn't use external any type of external libraries, but the performance was not good. So in 2014, it appears asynchronous loggers. This improves the performance because it achieves to reduce the latency and to improve the throughput. That concepts are the latency is the required time to perform an action, and the throughput is the number of executed actions per time. So to increase the performance, what we are looking for is to reduce the latency and to get a high throughput. Okay. And this is getting, by the way, to hand off the messages between the threads. Now, instead of the last implementation, it's using a LMAX Disruptor technology, which is an inter-thread communication library that achieves the higher throughput and the lower latency. Okay. So as we can see in this graphic, with 64 threads, the loggers asynchronous gets 68 times faster than synchronous, and 12 times faster than asynchronous appenders. So as you can see, if we increase the number of threads, the performance will be better. While in AsyncAppenders and synchronous will be constant. Okay.
Data processing. In data processing, we have many topics, but we want to show you some of these. We have Grails promises, as we mentioned before. You have to go to the speak tomorrow at 8:30. We can use the cache plugin, not the Hibernate cache, the cache plugin, Grails plugin. You have to avoid repetitive querying, async processing without using any other tool, and gparse. About the cache plugin. The cache plugin is a Grails 2 and Grails 3 plugin, but the Grails 3 plugin is under development. What can do the cache plugin? The cache plugin can cache method responses and tags. So you can easily use it and configure. And you can only with configuration create different caches. But you have to be careful because the cached items has no timeout. So if you want to delete one, you have to do it manually or using the annotation that I want to show you. So how to use that plugin? It's very, very easy. When you configure it in your project and you have created the message cache, you have to use the cache put annotation in a method specifying the name of the cache you want to store the values and the key to use it. And then when this method is called, a new entry is created inside the cache. So how can we get the cached values? We can use the cacheable annotation specifying the same parameters, the name of the cache and the key to retrieve the value. And how to delete values? You can use the cache evict annotation with the same parameters. A trick that you can use is to combine annotations in a method if it does apply. So this is very quickly, but be careful. Okay. What about avoid repetitive querying? Suppose that we have the following code. We have a list of names with Homer, Marge, Bart, Lisa, Maggie, and up to 100 Simpson names. Suppose that we iterate over the list, and each name we find the character domain class and do some actions or perform any logical operations and then save it to the database. We can refactor this, changing the query to a character.findByName in list. So in that way, we only perform one query and not 100 queries. Another way that we can do with the following code is using a list of IDs instead of a list of names. we have an character.getID to obtain the value. Instead of using this, we can use the getAll methods to obtain all the characters for the given IDs. Okay? So it's very, very, very quickly. Okay? It's all you can eat. About async data processing. Without using any other tool, framework, or plugin, you can use async data processing in Grails using the threads of Java. For example, in this code, we are calculating 100 factorial with threads and shared memory. As you can see, we have a long result that will be used to store the final result. And we create 100 threads, and each thread calculate his partial result, and use the synchronize keyword to access synchronously to the shared memory. Then finally, we can join the threads, and then we have our result in the result variable. Or another use, we can process a request asynchronously. We have an action that performs a very large operation. Then that we can do is to start a new thread, and when the large operation finish, send an email or another kind of notification. Okay, so the user launch the action. He receives a message that we are working on it, and then in background we are executing our large process. So this is the result. A little async. And gParse. gParse is a framework to do concurrent tasks. It works with Java and Groovy. The main functionalities that this framework make concurrence programming very easy, and it provides us multiple solutions for parallelisms. Let's see a few of these ones. An example of gParse is to use each parallel that we can use to summarize numbers. Like in this example, we have to create the gParse pool with pool closure. And inside this closure, we have to define a new atomic integer that is a variable, shared variable. And then for a list of numbers, we can call the each parallel method to do the logical operation in parallel. Another thing that you can do with gParse is to make an async call. Like in the previous example, we have to do inside the with pool block, and then a closure or a method or whatever you want dot call async. You will call this method asynchronously. But gParse has more features. For example, actors, agents, data flow, fork join. If you want to know more about gParse, you can go to the official documentation or go to a talk from the past Greach from Alonso Torres that you can view in YouTube channel of Greach and the slides on SlideShare. And that is very, very interesting talk. So be careful with parallelism.
Okay. And what can we do to improve the performance in our views? First of all, we can compress the resources. We can use the asset pipelines plugin to minify the JavaScript files, the CSS files, or even you can group them all in a manifest and include that manifest in the view. Okay. You have to avoid ask for resources to external heavy sites. Okay, if you spend too much time getting the resources, you can download them, your JavaScript or CSS files locally. And you can use the content delivery network. What's that? This is a network of servers spread all over the world, which saves the resources statically in cache, and depending on the location of the visitors, the nearest server will give him the resources. Those CDNs can save HTML, CSS, JavaScript, images, or fonts, for example. As I told you, you have an origin server which receives the resources, and depending on the location of the user, for example, a user in London will ask for the resources, and the nearest CDN, which is the Dublins, will give him back the resources. Okay. So what I have to do to set it up? First of all, is to install two plugins: the CDN Asset Pipeline and the Karman. Okay. After that, you have to set up a cloud front, such as Amazon, for example. You have to put the CDN details in your config file, and after that, you only have to push the local assets to the cloud to use it. Moreover, we have to be careful with regular expressions. There is a tweet some years ago that Larry Otari says that you have to be careful with catastrophic backtracking, because in this example, for example, you can use, it is trying to search 12 elements divided with commas, and the 12th is the letter P. You have to get the result with different regular expressions, but the first one causes more than 80 operations, 80,000, sorry, and the second one uses only 100. You have to size your regular expressions operation with tools such as JRegEx Analyzer, RegExBuddy, or another you can read for that. Okay. So you have to be careful against backtracking. You have to be really sure that there is only one way to match the good result. Okay. And according to testing, we didn't want to go inside, because tomorrow's talk you can see everything you want to in the talk. Okay.
We know that is a little early, but it will be a great talk. And tools. There are many tools to measure performance. For example, Java Melody, App Dynamics, New Relic, and Dynatrace. About Java Melody, you have tomorrow a lightning talk from my buddy Miguel Angel. Java Melody to measure Grails App performance at 11:45. So if you want to learn about Java Melody, this is your lightning talk. And I'm going to speak you about Dynatrace. Dynatrace is a real-time application. With this application, you can monitor performance of your application, but not only your application, even your server or the other components that have your application. It's available to multiple technologies like .NET, Ruby, Groovy, Java, C#, and another. And it has two features that I think that are very, very well. Database monitoring, that, as I'm going to show you, this tool shows us the lowest or the worst queries in performance term, and the most repeated queries. Another good tool that App Dynamic Form has is to show you your server topology with auto-discovering. So you have to install an agent in your server, and then you will have the topology of your server. Let's review with some screenshots. This is the control panel. As you can see, it has a beautiful UI. And you can see in a simple look the main statistics about your application or your server. In this other screenshot, you can view the topology of a sample server. You can view how many components do we have in our server, and also you can see the dependencies between the components. So if you want to, for example, shut down a component, you know what other components will be affected. Even more, you can view the server statistics like memory use or CPU use. You can view, as I said before, logs about your Grails application or your server. You can see here the number of the count error and the level of that error. Even more, you can search by typing text for an error trace, or filtering by critically. So, about the database, as you can see, we can view the database statements and how many long are them. In this example, we have sample query, select location name. That is it looks like an Hibernate query, and it takes less than a second. So you have to use the correct tools to do a better work. So be careful with the tools that you use. And finally, conclusions.
The conclusions, okay. We have some tricks that you have to know. Performance doesn't only depend on Grails. You have improved the Grails performance. You can improve your Grails performance in many ways. You have to know that performance is a culture which has costs, but less than fix it later. You have to know that it's really easy to improve performance little by little, and that you can help yourself using tools to size your performance. Okay? And this is all. Thank you very much. And if you have any question, Alberto will answer all you want to.
Azafata. So, any question? Are you sleeping? Yeah? No? Okay. No question? So, thank you very much for coming, and we hope to enjoy this talk. Thank you.